Greetings, environmentalist. We're going to do this part of the biomes lesson today, and it's over the water-related ecosystems. A little bit about water. Water kind of is what drives the earth, and when we run out of fresh water supplies, we're going to have some serious issues as humans. I realize that most of the earth is covered with seawater. The technology is just not where it needs to be able to treat enough volumes of seawater to produce what people need for irrigation, for industrial processes, and then domestic processes of uses. So the protection of these waters is extremely important. So we're going to talk about how we divide water into three different sections or types, and then we're going to look at lake systems, since lakes are the primary vehicle by which we get drinking water throughout the United States. And then we're going to talk a little bit about some concerns for pollution and protection of those systems. So first, you've got to be able to have adequate sunlight and dissolved oxygen. So a little bit about dissolved oxygen. You'll learn more about this a little later, but dissolved oxygen is what's available for plants, fish, and other macroinvertebrates that live in something like an aquatic environment or a marine environment. So let's define a few terms, and then we'll come back to that thought. Marine means seawater, and seawater typically has above 20 parts per thousand on average, usually somewhere between 25-ish parts per thousand of salt. Where if you look at aquatic, which is freshwater, it's usually 1 or 2 parts per thousand and less of salt. So that means the brackish has to be somewhere in the middle. Brackish typically is around that 17 parts per thousand number. And of course that can vary if you're at a tidal flat where tides come in and out 1 or 2 times a day, mixing salt water with fresh water that's flowing in from streams off of a continent. Let's just say if we're in Oregon, there's rivers coming off of the mountains there feeding into the Pacific Ocean. Well, those are going to blend with the tide water, and of course they're fresh and the tide water's salty, so you get a combination effect. This area is actually critically important to the health of the ecosystem, especially of coral reefs and marine environments that are shoreline environments. So let's talk a little bit about how the importance of seawater chemistry plays for and freshwater for that matter, the chemistry plays for organisms like you'd see here. These are freshwater plants right here, aquatic plants. If the pH gets too acidic or it gets too base, which would be the other side of neutral pH, which is 7, then you can start to have some issues. Some organisms like slightly acidic water, some like slightly alkaline water. But when you start getting dramatic changes, especially within 1 day time frame, that can remarkably change the environment and actually lead to fish kills, to die-offs of corals, the list goes on. So we got to have a number of factors that make a water system work properly. If we don't have those systems in place, the ecosystem is not balanced. As you remember from earlier, ecosystems are so important because they rely on the populations to work together in their habitats and in the system that's there to be balanced. And if one thing's out of balance, an ecosystem can crumble. So the 3 parts of a lake, we'll focus on freshwater right now, which is the aquatic system. I think you need to be careful when you're talking about aquatics that you don't use that term interchangeably with marine. Marine is its own environment with a very specific set of requirements, and the requirements for animals there and plants is not the same as it is an aquatic environment for freshwater. There are some freshwater systems that are much more saline than others, and making it challenging for certain organisms to live. So we're going to divide a lake into 3 parts, and then I'll explain the significance of why you needed to know those 3 parts besides testing purposes. Littoral refers to this area of a river or a stream feeding into a lake, and so you get this lake In geology, we call lakes lacustrine, but I'll refer to it just as a lake environment right now. So this is your entire lake system. Let's take the mountains away and call this Lake Waco. Or you can call it Belton Lake, or Stillhouse Hollow Lake, or Lake Mead in Nevada, or you can call it wherever you want it to be. But for the sake of our purposes today, we'll call it Lake Waco. So as water feeds in from the North Bosque, it's going to feed into these areas and pick up any pollution, sediments, and so forth that could be along this section of what we would call the riparian zone, and get mixed into this edge of the lake, the shallowest sections called the Littoral Zone. This is such an important area because this is where the life thrives of an aquatic system. It's the most productive part of a lake. It receives direct nutrients from runoff, rainfall runoff, or even point source runoff. Point source discharge can be traced back to its original source of origin, where non-point source can just come from all places when it rains and there's no way to really trace the source of pollution. Either way, it can end up in the littoral zone. That's one reason that we care about the riparian zone, which is the plant zone in this section, because if you have a good strong wetlands there, it can help filter out pollutants. And naturally occurring wetlands, or even man-made occurring wetlands, for example, the Waco Wetlands, provides us some very important resources to try and clean the water and allow adequate nutrients, but not too many nutrients. The problem with too many nutrients is you start getting some bacteria that will thrive to eat that in nature, and then some waterborne pathogens that come with that equation. So the risk for contaminated water is higher. What should you expect to see there? For testing purposes, I'm not going to be testing you about a bunch of plants names and animal names. This is so you get the picture, can understand the holistic view of what's going on in these different zones. You would expect to see aquatic plants like cattails and bulrush and lily pads and algae and things of that nature in terms of plants, but you'd expect to see tadpoles and frogs and turtles and little crustaceans and larvae of things like damselflies, and even some fish will be there to hang out to look for lunch. So this is a very important zone. I caught my largest fish ever in a littoral zone. That was like a 7.5-pound bass, and I was only like 6 when I did it. And I can remember thinking that was the biggest, bestest fish ever, right? Well, littoral zones are notorious for having fish come up in those areas to look for food. So the next zone is going to be this area right here called the limnetic. But before we leave the littoral, do you see the value of these aquatic plants around the edges of this system right here? All of this would be the littoral, so it helps filter out what's coming in. The limnetic zone is actually a much deeper zone. It's an area away from the littoral zone that extends into the deeper water, but sunlight can penetrate, allowing for photosynthesis to occur. No plants are going to be able to survive without photosynthesis unless they're chematosis type plants, and we certainly wouldn't have that in a lake situation, or should I say a normal lake situation. Having said that, your animals like fish are going to be directly reliant on some of those sources for food. So you'd expect to see more free-floating living organisms, and sometimes they're microscopic, but phytoplankton and zooplankton, you'll find your very large fish that would exist here. So as a fisherman or woman, that's why you might have a fish finder. Is in the limnetic zone, you're looking for the big daddy, right? You're looking for the one that's the big catch of the day. The limnetic zone is important in the fact that as you go down, less sunlight can be penetrated, but when you get to this dotted line, that is called the thermic line. The thermic line is where you pretty much lose that photosynthetic ability and a remarkable temperature change. And I will tell you from having done scuba diving in lakes, visibility change occurs as well. So these people are at the littoral zone, but out here, if they went to the wide open area of the lake, they would be in the limnetic zone. The Fundal Zone. Doesn't that just sound horrible? The name is just awful, isn't it? Fundal Zone is such an important zone of a lake, but it is kind of a nasty zone of the lake. It's this section way down here. So why is it nasty? It's the anoxic area where there's very little oxygen, and also it's where all the dead stuff accumulates. If there's chemicals or biological waste, such as sewage from boats that have been released, most of that ends up down here. It's really disgusting. So with that in mind, you got all this dead, decaying, nasty, wasty stuff down there. It's a bit smelly, right? And so on occasion, what will happen is you will get a lake turnover and a typical lake profile. Even in Texas, we have this happen. So people might remember that Waco area had some really nasty tasting water for years, for decades to be exact. My parents went to Baylor back in the 40s and 50s, and they had bad water back then too. So this has been a long-term endeavor, but it's not unique to Lake Waco. This is worldwide. This phenomena happens, what I'm fixing to describe. Waco, however, has done several things to try to improve this problem. So let me tell you how the lake turnover occurs, then we'll look at the time of year that it does. What will happen is when you get into a specific time of year where the temperature changes significantly around this thermic line, it will cause a shift, a flip-flop for a better lack of words, where the Fundal Zone water will scoop up, move up, and switch with what's up here at the top. So it's basically flipping it over. As that process flips, the nasty, icky, gross stuff at the bottom is moved up towards the top. So you're like, well, that's not so bad of a deal. Actually, it really isn't, because it's the lake's natural way of trying to clean itself. But here's where it gets a little tricky for humans. We have water intakes for lakes that are used for drinking water. Usually there's more than one. In the case of Waco, there's like 4 or 5 of them strategically located throughout the different depths of the lake for this very reason, and also for storm-related debris. If we normally pull from this intake up here, and we get a really horrible storm that brings in a bunch of debris, we're going to move our intake further down so we don't have to worry about that pollution source. The same would be true if we have the Fundal Zone. We're not going to be pulling down here when for drinking water when it's nasty water down there. However, we might pull from that depth if we get a lake turnover. So that's important to understand. There's absolutely no photosynthesis down there. It is nasty. It's an anaerobic, just gross area of a lake. If you've ever been diving into a lake in the Fundal Zone, it was not a pleasant experience. However, it is a natural course of every lake to have. So fall and spring test questions are the time of year that you should expect a lake turnover. It's because the surface water temperatures change, causing lower level of water to become displaced and literally to switch places with the current surface water. This is the lake's attempt to bring the nutrients to the surface and kind of clean itself. So it's like giving itself a spring cleaning, if you want to put it that way. So thermic lines are simply these areas that have these shifts in temperature, and those vary from season to season in a lake. In Lake Waco, we do not have full-scale turnovers like most lakes do. And the reason is that we have an aerator installed at the Waco Dam. And an aerator is simply a device that spins water. And the spinning of the water is simply designed to help mix the temperature of the water to reduce the speed or significance of a lake turnover. There used to be several more of these aerators in the lake, but when the level of the lake was brought up by 7 feet over 10 years ago, these others were taken out of service. So that brings me to understanding the value of nature's natural cleaners. Since we talked about the littoral zone and the value of aquatic plants, let's talk about freshwater wetlands now and discuss its value. Wetlands are basically areas that are covered with some form of water for majority of the year. It can be intermittent, it doesn't have to be full year round, and the depth is not quantified in terms of how deep that water must be. There are naturally occurring wetlands all over the world. Most wetlands property is not considered extremely valuable because it doesn't look very pretty. However, it is a wonderful nature preserve, and it's also nature's natural cleaner. And so it is a filterer. It just does an amazing job of cleaning water. And here's how. Because the plants are there, the flow of water tends to slow down. The plants eat what they need in terms of nutrients and food resources out of the water. So if you had a bunch of septic waste that that had gotten into from a leaking septic tank or from a wastewater treatment plant that released a bunch of raw sewage, then that would be coming through the wetlands. The plants would eat as much as they possibly could of those nutrients, and bacteria would try to finish the rest of it if it could. So typically what will happen is through the pathway of a natural wetlands, water becomes much cleaner from the entry point to the discharge point. And you can intentionally design a wetlands like the Waco Wetlands to achieve that very purpose. If you build a wetlands, they will come. The animals will come. And we discovered that full-heartedly at the Waco Wetlands. Not just when we built it, but every time it's gone dry for maintenance to work on the wetlands, the animals go away and then they come back as soon as it gets wet. It's really quite remarkable. So wetlands are nature's natural place for animals to come breed, to hunt, to have a place to stop in migration. They're very extremely valuable for so many reasons. So we initially established the Waco Wetlands in August of 2001. It seems to me, it's just hard for me to believe this thing is almost 15 years old. And I was there planting the wetlands the day that we actually opened it to the public. This building was not there at that time in 2001. It was built with some congressional money that we were given to build the education center. But the wetlands started off with one of the four major cells, which are in the wetlands. To be built first had to be the nursery, and the nursery was where you would plant the transplants that we brought in, literally transplants from plants in aquatic places throughout the state. We brought them in and transplanted them into the wetlands nursery to grow so we would have enough plants to make the wetlands work. So this was a long-term project, and within a few years we had all the cells operational and the wetlands was wet because we put a pump into the wetlands to pump water from the North Bosque River, and of course it rejoins back into where the North Bosque feeds into Lake Waco. That's where the Lake Waco Wetlands water goes. And at max, about 20 to 25% of the flow of the river actually goes through the wetlands. But it is a substantial improvement of water quality from the entry point to the discharge point. We've had MCC students out there volunteering for years and doing work just like you see here and whatever needed to be done, because the wetlands doesn't just take care of itself. We've had some problems with some invasive species or even native species becoming a little bit too hoggy of the resources. And that's what these students are working on in the background, is removing cattails. Cattails can be very nice in an aquatic environment, but in the case of the Waco Wetlands, they're kind of like rampant. They are everywhere, and we want multiple different plants to grow in that particular area. So estuaries are much like wetlands, except they're at the edge of a continent or an island where fresh water meets the ocean. And so this is an important breeding ground for just about everything that takes root around coral reefs or even along the edge of a continent. So they are a form of wetlands, by the way. There's like half a dozen to a dozen different types of wetlands. So why are estuaries so important? They are just like wetlands in the fact that they filter out systems for that water coming off of the continent or island feeding into the ocean. And they also serve as a breeding ground. These are very important places because of how nutrient rich they are. The salinity varies, so a number of organisms can sustain a little bit higher salinities and live in those environments, but not all the way out in the ocean. or if they're ocean animals, they can come into a slightly less saline area and survive during high tide conditions. It's a very important resource for that reason. But typically, estuaries are not thought of as being the most beautiful or sought after locations. Some of them are protected, like the Florida Everglades, but some estuaries just are not that beautiful. Others are really nice, like these that you see here. But you could expect to see animals like this. If you're in a tropical setting, manatees come into tropical estuaries to breed and to have their calves. So important thoughts to understand the value of that system. So in an estuary, there's two types that we're going to learn about for your test. The first type are salt marshes. We won't have these in Central Texas. Salt marshes. We could have some of these in Texas, especially along areas like Galveston or Padre Island. This would be a good example of a temperate area that produces salt marshes. But anytime you get an estuary, you'll get lots of nutrients from the land, and it's circulated with the tidal flow that comes in and out. And it has adequate light conditions to thrive for photosynthesis and just a wide variety of plant species, including one that you would find in mangrove swamps in tropical areas, which is this one right here. These are mangrove trees. Tropical regions bear mangrove trees, and notice they kind of have some strange looking root systems. While they may not look that attractive, mangroves are extremely important to the survival of many fish species, coral reef species, breeding grounds for various different organisms. It's quite important, and from a geologic point of view, it also is important for anchoring in shorelines from erosion. So we're going to look at that because areas that are estuaries have been decimated over the last century, in particular with the growth and utilization of commercial activity, resorts, boating, so forth, that's taken place along coastal areas. So let's take a look at that. Mangroves are just incredible plants that protect our coastlines. In areas that have been impacted by major tsunamis and their mangroves were intact, those areas didn't lose nearly as much of their shoreline deposits that areas that had removed them did. And so mangroves stay kind of dry during low tide, and they get submerged and saturated during high tide. So they're like one of the only tree species in the world that can survive in saline waters. And they are remarkable at doing a job just like aquatic plants do in a wetlands. Their job is doing that in a tropical area. So let's talk about the last star of areas that are impacted by water quality, and those are coral reefs. Now, corals have very, very specific needs. They must live in temperatures of 68 to 82 degrees Fahrenheit, so they're kind of picky, and these are photosynthetic type corals. There are corals that live at the bottom of the ocean, but they live off of chemicals, so they don't photosynthesize. All corals are actually made out of a rock material called CaCO3, which equates to calcium carbonate. And ultimately they'll turn into limestone when they die. But they make their own structures. Corals are much like mangroves in the sense that they help protect our shorelines from erosion. So if we have a healthy coral population and we get a hurricane along the coast area, it can actually help with storm surge. The same would be true with tsunamis. What is important to understand is the sensitivity of coral reefs to changes in their living conditions, such as pH, nutrients like from septic waste from boats, pollution from land. This can be very devastating to corals because if it blocks their sunlight or it contains contaminants that eat them, like bacteria or some kind of pathogen, corals just can't survive that. Corals live in a very narrow window of opportunity around the world because of their very narrow conditions of which they can live in. So let's take a look at a healthy coral reef and an unhealthy coral reef and see if you can notice the difference. This is basically the same geographic region in the Caribbean. So you need to tell me, as you're looking at this, which one's the healthy one and why. Don't just judge it by the colors. Don't just judge it by vibrance of life. Tell me what you're seeing that's different. And when you look, I mean, you knew right away that this was the healthy one, all the fish. But most people don't know that a coral reef typically looks like this. Now, if you get in super salty waters like the Red Sea, some of these might be brighter colors. And most of the bright colors in coral reefs are typically sponges, but some coral species are known to have very colorful pigmentation and salty, salty, salty type water. So what's happened here is we got nice clear water, good circulation, adequate nutrients, so the fish are flocking to the corals. I'll tell you flat out, many species of fish eat the corals. If you didn't know that, you will if you ever dive. And it is kind of fun to watch things like damselfish and other types of fish just beat the heck out of these corals trying to get the algae out of them. Having said that, these two situations are not in a healthy place. These are dead corals right here, staghorn, and these staghorns right here are dying. Can you see how the white has taken away the pigmentation color right here? That is called bleaching. Bleaching, there's a lot of thoughts as to why bleaching occurs, but we know basically it starts with the fact that the photosynthetic process doesn't work very well. There's a number of coral reef diseases, and these diseases are not all related to humans. Some are not. Nevertheless, the impact to coral reefs in the last 100 or so years has been incredible in the Caribbean, and that is directly correlated to human activity and climate shift. So you look at this brain coral. If you don't know why it's called brain coral, you can tell just by looking at it, but we humans name these corals by things that they look like on the planet. So a very, very healthy brain coral. To give you a size comparison of how big that brain coral would be, that would be about the size of a maybe a lazy chair that you'd sit in. This one, definitely about the same size, but I want you to check out this big old black circle. The color should be this right here, the coral, but look at what's happened to this coloration right here. That's black banding disease, and that's going to eat away. It's a pathogen material that's eating away the algae that makes up the coral that it grows. So it's actually taking the corallites and taking the small microscopic animals that make it up, the colony, and eating it. This is going to kill this coral. So we're not exactly sure how these things come to be in coral reef systems. There are suspect theories, of which some are human pollution, things from septic waste from boats, pollution that washes off from shorelines, trash, and so forth. But nevertheless, this is a problem because these corals are dying. We will be moving on into our next lesson of endangered species when we return. Let me encourage you to understand that we'll have our first quiz on our meeting next week. And I want you to realize that you won't need to bring a Scantron, but that you will need to have a pen and or a pencil. I provide the quiz form of which you get back. Most of them are fill-in-the-blank questions, but they should be obvious to you. I mean, they should be something like, all right, this was not right about that question, and something that were major triggers from the biomes that we learned about, and then the water lesson that we just had. So I'll see you back in class next time. Bye.